about a NoSQL database. Then after that, you have another 10 questions. Yeah, so now we go to the database. What's the database? Database Management System, for short, DBMS. DBMS is a software that enables users to define, create, maintain, and local access to the database. So when you learn database, they contain different components, including DDL. DDL means the data definition language. They also have DML, means data manipulation language, and some control access, and utility services, and also can support ad hoc queries. So when we say database, they have included these 5 functions. So briefly, database history. The first database is developed about from 1960s. This is kind of a network database. That means that they model the data as a kind of graph. So this is called a network database. Then later on, we have a relation database. Then EF Code developed some new theory about relation data. So we have a relation database in 1970s. Then in 1990s, we have a new kind of database. This is very popular about OO database, means object-oriented database, and object relation database in 1990s. Then go to the 1995, we have the multi-type of the database, which can process different type of data, include the XM database, mobile database, geographic database, and embedded database. Yeah, so we have more and more types of different database and for the different kind of applications. Then in 2005, we have the big data change. Then we develop some new NoSQL database or some new SQL database. So today, we will focus on the NoSQL database. Then firstly, we compare 2 concepts about optional database and analytical database. We see what's the difference between the optional database and the analytical database. Optional database management system is also called OLTP. OLTP means online transaction processing database. This database have to support the online transaction process. So this database can support the update of the data in real time, and they have to support the ACID properties for a transaction. So when we say ACID properties, we mean the 4 properties for a transaction. Maybe you already learned in your database course, which include the atomic. Atomic means that all of the work in a transaction can complete, commit or fail, or none of it can complete. So each transaction should atomic. The second is C. C means consistent. Consistent means a transaction transforms the database from one consistent state to another consistent state. Consistency is defined in terms of constraints. For example, we have some constraints like the function dependency, like the value constraints. This value should be the positive and may be greater than some value. So this is called the value constraints. So consistency means that each value of the data should satisfy some constraints. The third one is isolated. The result of any change made during a transaction are not visible until the transaction has committed. So each transaction should be isolated in their own processing. Then the fourth property is durable, means that the results of committed transaction survive failures, means that the results should be true forever. It's durable even with the failures, means that the data have to be written to a hard disk. So this is durable properties. Now we have the 4 property A, atomic, consistent, isolated, and durable. Yeah, this is the mainstream of the different type of optional database. Maybe you already know about Microsoft SQL Server and like Oracle, IBM DB2 and SAP and MongoDB, and yes, all this database are kind of the optional database systems, means that they can support the transaction and satisfy the ACID property. Yeah, so the second definition about analytical database. Analytical database is referred as OLAP, means that online analytical processing database. So this kind of database cannot support the transaction, but their main purpose is for analytical of data, analyze data. Yeah, so in this kind of database, they mainly focus on static data, no update for those data. And their main benefit are faster query performance because they usually have to process large size of data. So they have faster query performance and better maintenance and scalability. Yeah, so this is OLAP, analytical database. So these tables compare different type of optional database and analytical database. They can also classify as the NoSQL technology. And SQL technology means traditional relation database. For example, for your SQL technology, we have optional database like MySQL, SQL Server, and Oracle. All of them belong to some optional SQL technology. And for the part analytical database and SQL technology, we have the SQL Server because SQL Server have some product about the data warehouse. So this support the analytical of data. Yeah, so they have some relation and analytics function. When we go to the NoSQL technology, they have some optional database like the document store, key value store, and the column value store. We will introduce the detail later. Then they also have Hadoop and HD Insight. This is the big data analytics. So Hadoop actually belongs to the analytical database and the NoSQL technology. Because in most of the Hadoop components, they cannot support the ACID properties. So this belongs to analytical data. Yeah, so now we see the definition of the NoSQL. What means of NoSQL? NoSQL means that not only SQL, means that we have something beyond SQL. This is a new kind of database. It's next generation database addressing some points for big data challenge. This is a kind of non-relation database. It's distributed, open source, and horizontally scalable. Yes, this is some new feature about a NoSQL database, non-relation, distributed, open source, and horizontally scalable. Yeah, we have a lot of products or open source software for the NoSQL database. Maybe you already know some Hadoop or HDFS or Cassandra, CouchDB, or some memory-based Neo4j and Redis and so on. Yeah, so these are different type. Now we have maybe more than 100 different type of NoSQL database. Yeah, why we need a NoSQL database? This is maybe because of the big data challenge. RDBS can scale up. Scale up means that we want to use one machine and increase the more hardware processing power. So this is scale up, but scale up is not enough. It will meet the ceiling. So scale out is a solution. Scale out means that we want to add more machines. So this is called a scale out, means that we can use more machine to process a single job. So scale out is the solution. Yeah, so when we say a scale out, then we have to define new kind of transaction. Because in NoSQL database, it cannot support ACID property, but it will be used cap theory and to support the base property. Yeah, so now I will introduce new theory about the distributed transaction, which is called the CAP theorem, CAP theorem. Cap theory means that they will include the three different properties for our systems. The first one is consistency. But this consistency is not the same as previous consistency for the A-seed property. This consistency means that all copies have the same values. So they have different meanings. This means all copies have the same value, but the previous A-seed consistency means each data value satisfies the different data constraint. Yeah, so their meaning are different. So the same in cap theory means that all copies have the same value. Availability means that the system can run even if part of the systems have failed, because they have some replications. So they can maintain the availability even if there are some failures for some machines. Then the third one is P called partition. Partition means that the network can break into two or more parts, each with active systems that can't talk to each other. Even the whole systems, whole clusters has been broken into different parts, the system still can run. So this is called the tolerance of partitions. Then cap theories prove that this is impossible for a distributed data store to simultaneously provide all three of the guarantees. Means that this is impossible to support all these three properties for a single distributed systems. This is the main idea of cap theory. So we give the more detail about these three different properties. First is the consistency. Consistency, as said before, all nodes should see the same data at the same time. Means that if we have the variable x in two different machines, this 2x should be maintained always the same. So this is called the consistency for the data value. Then this consistency is not the same as the consistency in A-seed, but this consistency is more like atomic in the A-seed transaction property. So the first is consistency. The second is availability. Availability means that node failure do not prevent survivors from continue to operate. Means that the system always is available even if some node is failure. So means that each operation must terminate on an intended response time. Okay. The third one is the partition tolerance, means that the system continues to operate despite arbitrary message loss. So if we have some partitions, means that have some problem of the network between these two nodes, two machines. So we still can operate the whole systems. Each component the whole system should still be available. Operations can be complete. So this is called the partition of the tolerance. Okay, we have three properties: consistency, available, and partition tolerance. So cap theory tells us that only two guarantees can provide for each systems. Therefore, we have three different combinations for the three properties. If the systems can support the property of consistency and availability, then these systems have some example like the RDBMS. So RDBMS can support the consistency and the availability, because most RDBMS can have only single machines. Of course, they can support consistency. But if they have multiple machines, then they cannot tolerance for the partition. So the relation database is some example support CA, means that there's two properties. If we have a second combination about consistency and partition tolerance, CP, in some examples like MongoDB, HBase, and Redis. This can support the consistency and the partition tolerance, but sometimes they are not available in some case. So this is a CP property. Finally, the third type is support AP. AP is have some example like the CouchDB. CouchDB is document database and can suggest column database, and the DynamoDB is KV database and rack. Yeah, so this kind of database, they can support availability and the partition tolerance, but sometimes they are not consistency. Yes, so these are some examples for the different two properties of the database products. Some examples. Yes, so most of the NoSQL database support eventually consistency, means that they cannot support the strong consistency. Yes, so they can only support the eventual consistency. What's the meaning of eventual consistency? Means that when no update occur for a long period of time, eventually all the updates will propagate through the system and all nodes will be consistency. That means that all the different parts of the machine will not be consistency in some time, but when no update occur for a long period of time, then eventually, maybe take even 1 day or 2 days, then eventually all updates will propagate through the system and all nodes will be consistency. Yeah, so that means that eventually consistency means this is not a real-time consistency. This have some latency of the time. Yeah, so this is called eventual consistency. Yeah, eventual consistency can be defined as base. Base, B-A-S-E. Base means basically available, software state, and eventual consistency. So we call the base consistency, which is opposed as ACID. Yeah, so this is soft consistency model. Yeah, so base means B means basically available software state and eventually consistency. Base. So NoSQL database can support only base properties in most cases. Then base property have some features like this is a weak consistency. Still data is okay in some period of time. So this is not strong, it's a weak consistency. And this is availability first, and it's have the best effort to maintain a consistency. This will be simpler and faster for the NoSQL database, for the base properties. Yeah, so this is the weak consistency for the NoSQL database, which is different from ACID property. Okay. And now we give some example for a different type of the NoSQL database. NoSQL database can be classified, have 5 different types. They can classify it as column database, document database, key-value database, graph database, and multimodal database. So we have the 5 types of the NoSQL database. These are representative different database products for each type of data. We will introduce each type in more details. Yeah, so firstly, we see the column database. A column-oriented DBMS is a database management systems which store the data table as a section of column data rather than the rows of data. So they store data by the column, by the vertical way. A column-oriented DBMS has advantage for data warehouse, clinical data analysis, customer relationship management system, and the library card category and other ad hoc inquiry systems. Yeah, so the column database is mainly used for analysis of the data because they store data by column, so it's more convenient to get some aggregation values for one column. So we can see this example. If we have one table, this table is very simple, include 4 different attributes. The first one is row ID, the second is employee ID and name and age. If we use the row-oriented storage, then we will store this table information by rows. So we will first store the first row, 1, 1, 2, 3, and I know 34 years. So we will store this row, then by the second row, the last one. Yeah, so this is row-oriented storage in file systems. However, if we want to use the column-oriented storage, then we will store them by the columns. Means that we will combine 1, 2, 3, 4, 5, 6, 7, 8, 9 columns together in one block of the file system. Yeah, so we will store like column-based. Yeah, you can see they use a different way to decompose the data in the tables and store them to the file systems. When we store all the data by row, then we are very easy to get the one row information together. For example, if we have a SQL query which want to find the ID is 1, 2, 3 and want to retrieve all information about this about the name and age for one particular employee, then this will be easy to do implementation by the row-oriented storage. Yeah, but if we want to use column storage, then we have to do the jump, to do the seek operation in a different block of the data. For this example, if we want to retrieve this row information, then in the row-oriented storage, then we can just access this block of the data. But if we use the column-oriented storage, in order to get this row information, we have to access different block. In this block, we have to get this information and this and this. So if we use column-based storage for the SQL query, for some selection queries, then maybe we have more cost. This is not very efficient for the column-based storage. But the advantage of the column storage is that it can do aggregation for the single column very efficiently. Means that if we want to get the sum or the age, or we want to compute the average age for all the employees, then we can very easily to retrieve all data in the single column in one block of the column-based database. Yeah. So in this example, we show that column storage is very efficient for some aggregation operation for one column. But row-oriented database is very efficient for the selection of one tuple or one row information. Yeah, so this is a key difference between the row-based storage and the column-based storage. Yeah, so this is difference. Yeah, so the second store is key value store. Key value store is very simple. Just we use an associative array as a fundamental data models. Means that for each data value, we just store key and value. This is a pair of the data. Yeah, so we can see examples to understand the key value store. Yeah, then we go to the previous examples. In order to store these tables, we have some key value information. For example, we can set the key as a row ID. So we store key and value. In this example, value may be the combination of the 3 different column values. So in this example, row ID is 1, then these 3 different attributes can be combined as a value of this key. Yeah, so we use this way to do the key value storage, which is different from the row storage and the column storage. This is called the key value storage of the data. Okay. Yeah, in these examples, key value storage, they are very efficient for the insert of one column for part of the data. For examples, if we want to add a new attribute for these tables, If, for example, we want to add the salary, but this salary can be only added for the employee of Jiaheng. Yeah, so in these examples, when we use the key value storage, which will be implemented very efficient, we can only modify the records, the information for the key 4, and add the 30,000 as its salary date. Yeah, so this example shows that for the key value storage, we are be very efficient to insert one column information. Yeah, but if you use the row storage, then you have to use a different way to store this 30,000, because you have to store some empty data here, because we have no salary for other 3 employees. Yeah, so we have to use more space in the column-oriented storage and the row-oriented storage. But in the key value storage, this is very efficient and flexible. Yeah, so the next, the third type of database is document database, document store. Document store means that we just store the whole document in the database. We can encoding them as XML data or the JSON data or the BSON data. BSON data means binary form of the JSON data. Yeah, so documents are addressed in database via a unique key that represents the document. So we just store the document and their key. Then this is an example of the document store. If we want to store some information about University of Helsinki, then we can encode it as an XML file or with some JSON files. Yeah, so there's some examples. We have to add some tag. This tag is schema information for this data. Yeah, so we can store this as an XML file or a JSON file. They have the same information. Yeah, so the fourth database is the graph store. The purpose of graph store, of course, is to store the whole graph. They have some application in the social relations and public transportation link and like a social network. And yeah, so we just use the graph. Graph include the node and the edge. Each node have some key value pairs. This graph called the property graph means that each node maybe have multiple properties. So in these examples, this node have 3 different properties about the type, name, and age about this data node information, and they also have age. This is directed graph, and they have some arrow, and they also have some labels for each age. So this kind of graph called the property graph data. Yeah, the last NoSQL database is about multimodal stores. Multimodal, of course, this means that this database can support multimodals. They can support the multimodal data against a single integrated backend, which may include all the previous 4 different types of data, like document, graph, relation, key-value columns, all can be included as multimodal data. For example, we have some different type of the multimodal data product. Yeah, so in these tables, we just want to compare their features to support the different type of the data, and there are some feature about transaction. Yeah, so this gives some example about OLTP. This previously is a graph database. Now they have to be extended to support the different type of the data. The second one is CouchDB. CouchDB is a document database. They are mainly focused on the JSON files, but now they can also support SQL and key-value. And the last one is MacLogic. MacLogic is an XML database, but they can also do some extension for the multimodal data. Okay, yes, so we also do some research about multimodal data. We want to develop some new kind of the unified database. This is multimodal database. This database can combine the different data model together in a single database system. Yeah, so we give some examples. We develop some new data about the e-commerce, means that we develop some new benchmarking systems which can do a query processing for some e-commerce applications. In the e-commerce applications, each customer have different type of the data. For example, customer may have some order and product information which can be stored in JSON files. And the customer have some social network. They can be put in the graph database. And the customer can have some name and some attribute, have some relation tables information. And the invoice of purchase can be encoded as XML document. Yeah, so in our typical e-commerce applications, then we can store all the information with different format to one single multimodal database. Okay, this is some example about multimodal query and the data. In this example, we show the one table and the JSON files. Assume one customer have the different type of data. Some information is stored in a customer tables, include the name, age, and gender. Those shows the different attributes for this customer. And this customer have some purchase history. They have some orders. Yeah, so they have an order ID, including some things they have bought in the e-commerce applications. Yeah, so we can issue one query. This kind of query is do some extension for the SQL query, but we want to do a join between the relation table and the JSON file. So this is select from where. This is very similar as the SQL query language. Means that we want to see some custom name, and to do a join by the custom name and here custom name between the table and the JSON file. And we want to find the customer have some orders contains bag, means that we want to find all the name of customer which already buy some bag information. This is a very simple query, but this have to do the join, to do the cross join between the table and the JSON file. Yeah, so this kind of query called multimodal queries. Yeah, so this is a second example of the multimodal queries. This is more complicated than the previous one, but the idea is same. We want to do the join between the customer table and the order JSON, and we want to order all the information by the age of these customers. Yeah, so this is the answer. If we want to encode, we want to output our answer by the JSON files. Yeah, so we can, or we can output its array. So we can output there's two different tuples. M means that the name. Yeah, here because C name as M. So G means the gender. Yeah, so we want to output the information about these two customers and order them by the age, by ascending order. Okay, yeah, this is the example of multimodal queries and their answers. Yeah, if you are interested in the research and the development of the multimodal database, then we have made a tutorial in the last year conference about EDBTU, and then we can read our paper and our more slides about this kind of the research. Yeah, okay, yeah, so now I make a conclusion about this lecture. We already talked 3 different topics. Firstly, I introduced some 4V about the big data. Then I introduced some Hadoop and HDFS as the big data framework. Finally, I gave some introduction about the NoSQL database, and I introduced 5 types of different NoSQL database. Okay. Yes, this is our paper published about the big data. And if you are interested, we have some paper about the graph database and about the HDFS tooling and about some survey and about some multimodal data management. Yeah, okay, yeah, this is my email. And if you have some questions, then you can send me email and ask me at a time. Yeah, so next, we can do the second exercises.
This is the same procedure. They are discussed between you and these are multiple sides. This is the type 1. So these are true or false. Just